Welcome. This is Cat Off the Table for Group 4 for ECE 405, aka Senior Design 3.
Yeah, and so let's get into the design of the system. So first we'll get into the hardware. So for the power of the system, we're using a 12 volt AC to DC power converter, and then we're using two buck converters. The buck converters are taking 12 volts and bucking them down to 7 volts and 5 volts. The reason we're using two is because one is isolated for the Raspberry Pi 4, because the Raspberry Pi 4 is a little bit picky with its power supply, and if it has a fluctuating current, it can shut down the system, which we can't have with this design. And then we've got the 7 volts that is powering the pan and tilt, and then the internal pump and the solenoid to control the water. Also, we got the aiming hardware, so we have a pan and tilt, which is two servo motors. One goes left and right, one goes up and down. They're taking 7 volts and receiving pulse width modulation from the Raspberry Pi 4 to control the aiming of the device. And then we've also got a water level sensor. So this is a float switch that basically just opens when the water level goes below a certain point. And the way that that is designed is there's two capacitors in parallel and a 555 timer. And the frequency will half when the capacitance doubles with the 555 timer.
Yeah, basically it gets triggered.
So in our detection script, we are using YOLO, which stands for you only look once. So that literally means the model is grabbing a frame and looking at the whole image all at once. It does this through 3 parts, first with the backbone that extracts the features, then through the neck, which will scale up certain parts of the image to detect either small or big objects, and then through the head, which then will make a prediction on the objects in the image, which will then pass confidence and classify it. In our script, we are grabbing a single frame from the camera. It will then display that frame plus the overlay of the predicted bounding box in the center, and then also the FPS that it is running, and then it will also pass the coordinates of the center of the bounding box and the confidence to our move script, which will decide where the camera and the shooting mechanism will look at, and then also whether to shoot or not to shoot.
Yep. And then with the Raspberry Pi 4 here, as you can see, it's got a touchscreen interface, which is something that you can use when you're working with it. What I did is that I've set up a log rotation system to deal with journal files that get too full since we've created new scripts, and the system doesn't know how to handle that, so you got to do it on your own. And then that comes with the system D service, so you can set it up to send the information to the journal files. And then I also have Chrome jobs set up on here to do auto updates to the system, so we don't have to do it ourselves. And it also cleans the cache for us, because sometimes that gets a little full.
Yeah, and basically the way the whole software system works is it has multiple scripts running in parallel. The main script, so you got the YOLO, and then you've got a main script. The master script calls the pan and tilt logic, the YOLO,
Float, and our pump and solenoid.
Yep.
And so those are our worker scripts, and our master script will then have those communicate using shared memory.